Great Wall was constructed over 2,000 years ago, and the various documents remaining shows the distance between the cities in China and Korea and all the way to Kyushu Island in Japan. Ancient people measured the distance between cities. Between cities there may be rivers and forests, and you cannot just walk and measure, right? So there are civil engineers working on those, and according to Empire's record, civil engineer group was in charge of making a new irrigation, river connections, or building something, bridges and all kinds of things. So they were very smart that time. Okay, here I show you how they measure the distance. Okay, say there is a one tall object. Okay, we use a measurement stick, typically like 2 meters. At that time they have their own measurement unit, okay, just like a foot, yard and stuff, but we use a metric here. So say we have a stick, we can put it up on the ground vertically. The way it does vertically is you hang something, the weight, and this like the string hang the weight, it's gonna define the vertical line, so it can be vertical pretty accurate. Suppose you want to know the distance L, right? And what you do is you put up this stick and look through the long tube and look at this reference point, okay, and measure A. Now you move this stick arbitrary amount, but it's not really arbitrary, I explain that later. Then you measure distance B same way, but this time you need to know M, okay? M is how much you moved from here. Okay, so that's all you need to do. So two triangles created by stick S are similar to the large triangle. Okay, so this triangle is similar to this, right? And this triangle is similar to this, right? So using this, height is S, the ratio L over A, and also the ratio S L plus M, this total distance, over B. Okay, so you solve this equation, then you get distance L. You measure M and A and B. Now be careful, here's a division, and division was very hard to do in the ancient people. Ancient people knew how to divide 2 and divide again 4, divide again 8, kind of division. If you ask them divide by 6, or they scratch the head. So when you move the stick, make sure B minus A will be the multiple of 2, okay? Then they can calculate division easily. So it's arbitrary how far you can move. So you can adjust so that the B minus A will be the multiple of 2 of the unit measurement. Okay, so from here we substitute this back to here, we get the height. This is the height of reference point. Okay, so this is a simple method. You can determine the distance and the height. That's what ancient people did. Okay, and here's the two examples. Example 1, example 2. You use a 4-meter stick, put it up vertically, and on top has a long tube you can look through and aim at the reference point. Okay, and this extend, then measure this length. That's A. You do same thing for B, and you measure the distance from here to here. That's the M. Okay, for this example, the height is 1500 meter high and distance is 12 kilometers. Okay, now the large scale example, 8,000 meter high. It's a very high mountain. If you can see the high mountain from far away, like a 40 kilometer away, then you can do the same thing. Okay, so that's how ancient people measured distance and height. Okay, now when you have a city A and B, use the same reference point, you can measure L1 and L2 distance. But how do you measure the distance between city A to B? Okay, so what we do is, they of course know how to use compass. Let's put the string and draw the circle, and put the string and draw the circle. But this is not the real scale. They do that of course for the shrunken scale. Okay, scaling, they have no problem. Okay, now from here they determine the direction against this reference, this direction. Okay, so this direction, they draw the line on this circle, then they measure this length. It's scaled length of the distance. That's how determine the distance. And that's why in the various books we can find a description like city A is located from say 100 kilometer from city B, and A to even go over the ocean to the island even has that distance, because island has a mountain and they measure the mountain same way that they measure the distance. So that kind of description existing in the book, that means they know how to measure. I mean, you cannot walk on the ocean to measure the distance, so definitely they are using the method. Okay, so interesting fact here is ancient people knew the direction by invention of the compass. You know, the Chinese compass was initially invented by the spoon. They put the spoon on a plate and spoon point north. The spoon happened to be magnetized. Okay, so that's the way the compass was invented initially. Okay, and tall object is like a hills, a mountain, or temple on the top of the mountain, and if there's a flat area, there's nothing tall, then fireworks was used. Interesting. Civil engineer, you need to use the firework, and they see fireworks from far away, and they know the direction, and that's the way they know. So even you have a rivers and a forest in the middle, they put fireworks and they see the direction. Oh boy, pretty fireworks here. So they kind of determine the direction and draw the line on the map and measure the distance. Okay, so the gunpowder was also invented in China, and kind of nothing to do with this civil engineering, but the first weapon made with the gunpowder was a missile, not the gun. You know, the fireworks shoot and hit the enemy. So it's kind of missile. That was the first weapon made. The gun was created much later. Okay, so that's a kind of interesting ancient story, but it's a good algebra, geometry and algebra study. So I hope you enjoyed this video, and please check out the video too. Thank you.